Good morning, guys. Welcome back to the Blackboard. We are going to continue with the inner product spaces chapters and do three different examples that's going to primarily focus on what we talked about in the first half of the lecture, which is pretty much lengths. So with that being said, we're just going to get right into it. So the first one asks us to find the length of each vector. So that's just pretty much asking us to find the magnitude. No big deal if you remember how to calculate the magnitude. So for the first one, you've probably done it a couple times. I mean, this is pretty much like Pythagorean theorem. So our magnitude v is going to equal to the square root of 4 squared plus 3 squared, and we all know that these are triplets, so this is gonna be 5. So if you want the work, would be 16 plus 9 quantity squared, which is equal to square root of 25, which is equal to 5. Cool. So part B is telling us to find a vector of 1, 2, 2. It's really no different than the one that we did previously. The only thing is you're just adding a second term. You're not supposed to add. So again, it'll be square root of the sum of all the squares of everything, or of the coordinates. So that'll be square root of, not square root, 1 squared is 1, then plus 4 plus 4. 4 plus 4 is 8, plus 1 is 9. So this is the square root of 9, which is equal to 3. And then our last one, again, it's just the same thing as the other two, just dealing with an extra term. So you'll have 2 squared plus 0 squared plus negative 5 squared plus 5 squared. And as you can see here, that negative 5 becomes positive because you have 4. We're just going to ignore the 0 because it's 0. So negative 5 squared is 25 plus an extra 25, and you'll get square root you'll get square root of 54 because 25 plus 25 is 50 plus 4. Take the square root of that, and there you go. You got what do you got? Get your answer. If you want to simplify even more, well, that means go ahead. So yeah, that was pretty much it for the first example. Pretty short, pretty easy. Like I said, this chapter is relatively easy than the past two. Oof. So let's move on to the next example. So this next example, we have to find the magnitude of u, the magnitude of v, and the magnitude of u plus v. And we found the magnitude, or we know how to find the magnitude of u and v, but u plus v, well, you just gotta do a little extra step, but it's doable. So let's go ahead and do it. So for u, magnitude of u, again, the usual square roots of the sum of the quantity squared. That 1/4, or I guess that 1 fraction, does not look really nice. So we got the square root of 1 plus 1 over 16, which is equal to square root of 17 over 16. You want to simplify this even more, this would be the square root of 17 over 4. So for v, again, same thing, square root of the sum squared. So 4, I don't know why I put that in parentheses, 4 squared plus negative 1/8 squared, like the square root, and that is equal to the square root of 16 plus 1 over 64. A little bit of quick math. 16 times 64, that will be 1025 over 64. Simplify this just a tad bit. a tad bit more, and you'll get that this is equal to 5 root 8 times the square root of 41. Yeah, it's 25, 41. Okay, yeah. So now for u plus v, well, before we find the magnitude, we need to find what u plus v is. And that is basic vector addition. So that'll be -1 plus 4, then 1/4 minus 1/8. So that'll just be equal to 3 1/8. And then you just find the magnitude. So not the square root. So the magnitude of u plus v is equal to 3 squared plus 1/8 quantity squared. Take the square root of all that. Get the square root of 9 plus 1/64. So 9 times 64 is 577. So you just I don't 577 should be a prime number, so our final answer should be square root of 577 divided by 8. So yeah, very simple, just a little bit more work. I mean, it's asking for more, but very doable. So now let's move on to the next part. So now we're going to be dealing with 3 instead of 2. 3D. So not the square root, magnitude of u. That's why did I do that? Why did I do that? It's equal. It's equal to the square root of 0 squared is 0, so we can just ignore that. 4 squared plus 3 squared. Take the square root. Again, it's a triplet, so this is 5. And look at the previous example for the extra work. So then the magnitude of v is the square root of 1 squared plus -2 squared plus 1 squared. All of that square rooted. And that is equal to the square root of 1 plus 1 is 1 plus 1, which is 2. And 2 squared is 6. So that would just be the square root of 6. And then we just gotta add u plus v. So that is equal to 0 plus 1, 4 minus 2, and then 3 plus 1. That will give us 1, 2, 4. Oh, so close for 1, 2, 3. Oh well. And now to take the magnitude, oh, you just take the magnitude like you always do on every other vector. So take the square root of 1 squared plus 2 squared plus 4 squared square root, and that would just be the square root of 1 plus 4 plus 16. 4 plus 16 is 20, so it'll be the square root of 21, and that is, yeah, you can't square root that because it'll be 7 and 3. Yeah, okay. So yeah, that is our answer. Cool, we finished the second example. So now we're gonna move on to our last example. I think it's the same number of parts. I could be wrong, but we will check. So let's go. So our last example is asking us to find the unit vector. Whoa. Unit vector is usually denoted as u. So, you know, u for unit. So we're just gonna go ahead and find a unit vector. For those of you who don't remember, you take the magnitude, you divide the vector by its magnitude to get the unit vector. So what we can do, or what we are gonna do, is we're gonna find the magnitude of v, or I guess the magnitude of the vector. Oh, they're all v. Magnitude of v. So there's no biggie. You've done this like already like 7 times, something like that. 6. I can't count. But let's find the magnitude. So -5 squared plus 12 squared. That is equal to square root 25 plus 144. This is another beautiful triplet, which is square root of 169. Nice. Which would be 13. So our unit vector, u, is going to be equal to the vector over its magnitude. So this would be -5, 12 all over 13. We distribute the 13 and we'll have -5 over 13, 12, 13. So that is our answer. Cool. Didn't even have to use a lot of space. So now for our next one, part B, do the same thing. Find the magnitude, 3 squared plus 2 squared plus -5 quantity squared. That is the same as the square root of 9 plus 4 plus 25. I really hope I'm doing this math right. 9 plus 12 is 13. So 25 plus 13 is equal to 38. Yep. So square root of 38 is our magnitude. So our unit vector, oh, that's gonna be not so nice. Our unit vector is gonna be the same thing. So it's 3 to -5 all over the square root of 38. Distribute it, so you get 3 over root 38. 2 over root 38, and then lastly -5 over root 38. So that is our answer. You can simplify this a little bit more by moving the square root of 38 on the top. So you just multiply both sides by, or you just multiply each thing by square root of 38 over square root of 38. But you know, this will do. This will do. Then our last example is so nothing different from the other two. Find the magnitude, so you get 1 squared plus 0, so that's 0, so 2 squared, 2 squared, and that should be square root of 9, which is equal to 3, because it's 1 plus 4 plus 4, and so our unit vector is going to be 1, 0, 2, 2, all over 3, which would be 1/3, 0, 2/3, and 2/3. And there you go. That is all the examples with just magnitude and unit vectors. There's a little bit of vector addition, but nothing too harsh, not a big deal. We've done this a couple times, I think. I hope. But yeah, that concludes this video. Our next example will work on the dot product and angles. So have a good rest of your day or evening, and I'll see you guys in the next video.